Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we will solve some problem related to the inclined plane surface when it is submerged in the liquid. So in the previous lecture, we have seen the theory part of this inclined plane surface when it is submerged in the liquid. Let's solve some problem related to this topic. So here I have taken a question, a rectangular plane surface 2 meter wide and 3 meter deep lies in a liquid in such a way that its plane makes an angle of 30° with the free surface of the water. Determine the total pressure and position of the center of pressure when the upper edge is 1.5 meter below the free surface of the liquid. Okay, so here only few data are given. That width is given and depth is given and the angle is given and the upper edge of the surface of free liquid that is given. So by that we need to draw the diagram and we need to identify the total pressure and position of center of pressure. So this plane, inclined plane, that means we need to make a first free surface of the liquid. So let's consider this is the free surface of the liquid, and as we know that, let's draw a line with an angle of theta here. So this theta angle is given 30° already given here. So theta equal to 30 we can write. Now this is the surface of the liquid, we can say, because initially this is the free surface of the liquid, but it makes an angle. Okay, inclined plane is there. So for that inclined plane, this is the free surface of the liquid. So here what I'll do, I just draw a rectangular plane here. Okay, let's see, assume that this is a rectangular plane, though it is not properly rectangular, but let's assume that. So here I'll do one center of gravity and the center of pressure. So this is the G point and this is the P point, and this is the inclined one is there. Now what I'll do, from here, this is the upper edge of this rectangular plane. So let me draw here one line, and from here to here we need to project the distance. And for the rectangular plane, the width is given 2 meter and the depth is given. Now this is the depth is there. Depth is 3 meter is there, and similarly width of this is given. Width is given here. This is 2 meter. Okay, so 2 meter width and 3 meter deep inside the liquid. Now this is inclined one. Okay, this is not the vertical one. If you keep it the vertical one, then it will be like, it should be like present like this. Okay, so and then we can say this is the depth and this is the width. Now this was make an angle of theta here. That's why it's look like this. And here also we need to just project the line here, and here also let's project the line. Now the height, we know that from this center of pressure to this free surface of the liquid, that is actually H star. So what I'll do, I'll draw a line from here and I'll give this one as the H star here as per the notations for the previous discussion. This one we can, and this height is nothing but our H bar. This height is nothing but our H bar. Now a few more things I can do here. This one, let give a point. This is C point, and let make this is the A point, and here this is the A, and this one we can give as a D point, AB and CD. And here let make a straight line of this from this point to here. How much distance? Not distance, actually let make a point here, that is E point, and the distance from this upper surface, from here to what is given, when the upper edge is 1.5 meter below than the free surface of the liquid. So that means if this is the free surface is there, from this object tool should be 1.5 meter. That means this point is situated nothing but from here to here, CD equal to 1.5 meter, and similarly we can write this one also 1.5 meter. Okay, Now these are the data are given for this question. Okay, so here let me write what are the things is given. Now width, let make it b equal to 2 meter and depth d equal to 3 meter. Okay, and the theta angle is given. Theta angle is nothing but 30 degree given. Now we need to calculate the total pressure of that, and total pressure we know that F equal to, in our previous lecture we have seen rho g ah bar. Okay, rho is rho g ah bar. So here we need to calculate the ah bar, because remaining things we know that here the density of the liquid, that is nothing but water, so we can write density equal to 1000 kg per meter cube. Okay, now similarly g is the acceleration due to the gravity. The value is, that is universal value is there, 9.81. And similarly area we can write, b into d, the width into depth we can write, that is 2 into 3, that is 6 meters square. And now only one thing we need to identify here, that is h bar. So h bar we can calculate in such a way that distance, how much height is there from here to here. So this, this point h bar is the distance actually from the free surface of the liquid to the center of gravity. Keep in mind, okay, the distance from the free surface of the liquid to the center of gravity. So this point actually, if you see, the upper layer of the surface from this free surface, from the free surface of the liquid, is situated 1.5 distance. Again, this h bar is situated with an angle. Now if I make this as a triangle, if I make a triangle of this, then what I can write here, now h bar equal to, we can write the value of this, only this part will be, we can write, okay, one more thing I'll tell you, otherwise we can write in this way, h bar equal to 1.5 meter from the upper surface of the liquid plus, this will be the upper surface of the liquid 1.5 into sine theta, so that will get 1.5, this is 1.5 sine theta, sine 30 degree, so sine 30 degree will get by 2, 1 by 2, this is 1.5 plus 0.75 will come, and it will get 2.25 meter. Or else we can write this h bar equal to, or else one more things we can write here, h bar equal to, we can write AE, okay, AE plus EB. What marking we have given here, see, this is the distance AE and plus EB is there. Now AE is already given, AE distance is this one, from this height 1.5 meter as I told you initially, so that is 1.5, and EB distance actually this one, so this one from here we have to, I have taken this big triangle here. Similarly here also I can draw a small triangle like this, and here I can see E point, B point, and this is C point, and this one make an angle of theta. So what will be the HB point, EB point? So that is nothing but this length, this length into sine theta. So that's why 1.5 sine 30 degree. So that's the same thing I have written directly here. Okay, so now we got the value of h bar. So we can put the value of h bar there, and we can find out 1000 into 9.81 into area 6 into this one 2.25. So near about what we'll get, let's see, 1000 into 9.81 into 6 into 2.25. So 1,32,435, 132,435. So that is the F. Okay, so this is the value of F, what we're getting, 132,435. This is the Newton. Okay, so this is the force value what we are going to get. Now similarly, if you see the value of H star, the formula of this H star equal to, we know that IG sine theta divided by AH bar plus h bar. This is the equation for the h star. Now here ig equal to, we know that ig equal to, for this rectangular plane we can say this is bdq by 12. So bdq by 12 is nothing but 2 into 3 to the power 3 divided by 12. 3 into 3 to the power 3, 3, 3, 9, 27, 27 into 2, 54 by 12. So that is near about 4.5 meter to the power 4. Now here we'll put the value of ig here, we'll get the h star value. Now ig we got 4.5 sine 30 degree divided by area 6 into h bar 2.25 plus here 2.25. So we'll get the value 4.5 into 1 by 2. So we'll get in about 2.25. 2.25 cancel, 1 by 6. 1 by 6, that will come 10 into 1.6 something will come. So then near about 0.8 will come here, plus we can say this is 2.25. So near about how much will come? 0.0 it will come here actually. So then 2.33 meter. So this is the answer for the h star, and this is the force, this one. Now here we can get easily the value of total pressure and the position of the center of pressure. Okay, now similarly one more problem, let's see. Here the problem is given in different, the problem related to the circular diameter, circular plate actually given. So previously we have seen the rectangular plane, now here it is given circular plate. Concept will be same, the same way we need to solve it. Okay, that means we need to consider a free surface of the liquid like this, and we need to give an okay, here it is given is immersed in diverting in such a way that its greatest and least depth below the free surface is a 4 meter and 1.5 meter. So here it is angle not given, okay, but it's given like suppose a circle is there. Circle is not coming properly here. Okay, okay, leave it like this. So this circle, what is given? So this is the axis point, like center point of this. Let's see, and this is one point, and this is one more point. So what is given here? And the circle diameter will be there. Okay. Now if I draw the height from here, from the free surface of the liquid, so this will be the height and this will be the height for this. And here, and the G point and H point, G point and P point will be both will be here. So that also it can here. So this is H bar, and this is here H star is not there. Here it will be actually this end point. You see it is given greatest point and least point depth, that is given. So least point is nothing but from here it is started. So that's why it is the least point, and the greatest point is the highest point of this circle. So that is here. So that will be actually 4 meter. And this will be actually 1.5 meter. And here theta is not given. Okay, theta is not given. So we need to identify the theta value here. And though this is 1.5 meter, so here also it will be 1.5 meter. Okay. Now this is H bar here, and these are the points we can give some names. CD, what we given previously, and this is B point. This is C, D, and B. And here, from here to here, you draw a just line, so that we'll get a triangle here like this. Okay, and this one A point, AB, and this one you give E point. Okay, so AB, CD, E point here, and theta angle is given. And here how much is given? Circle diameter 3 meter. So this is 3 meter here. So we need to find out the total pressure again. We need to find out the total pressure how much. Now here diameter given 3 meter, so you can calculate the area of the circle, that is pi by 4 d square. We'll get some value here. Now distance D equal to, let's see, 1.5 1.5. This is the value CD. This is the value CD, the distance from this upper end point to this free surface of the liquid, 1.5 meter. And here the distance from the highest point, that is you can see BE equal to 4.5 meter. So this will be pi by 4 into 3 into 3. So 27 by 4, that means 27, 28. 28 point something will be 4, that will be 7. Okay, 7 point some value will come, meter square will be there. Next, we need to find out the distance of the CG, from the free surface. Distance of CG from the free surface, that we can write h bar. We know that h bar equal to CD plus C. This is the height is there. So we know this up to this, we know the height from here to here. Suppose this is the G point and this is F point. Suppose FG we know. Okay, FG equal to CD. Now next to this point EGFH. Suppose H is there. Okay, so from F to H, how much will be there? So this one you can write in terms of theta. Okay, so this one we can write. Let's see. Similarly from here H, this one, so that we can write in terms of here this one, this HC sin theta. Okay, now what we can write this one, CD equal to, CD is nothing but GH. So here on behalf of CD we can write this is GH. So GH value how much? 1.5 plus HC. HC is also same, 1.5 is there, 1.5. This is your sin theta. Okay, so this is the equation. Now again the sin theta we can write, the sin theta equal to AB. Yeah, this one divided by BC. So we can write AB divided by BC. So this also you can write same thing. Here also the same 4 will be there. Sorry, how much height is there here? So now AB here 1.5 gone after 4. So remaining how much will be there? 2.5 will be there. So AB you can write AB. Let me elaborate this. EB minus AE. EB minus AE divided by BC will be there. BC. EB how much? 4 minus 1.5, so remaining 2.5 will be there. And BC height is how much here? You can see that is 3, because this is the height of this BC. So that is nothing but 3 is there. So this will get near about 0.8333. This is the value. Now this is the value of sin theta. Okay, the same sin theta value we can put it there. So what we'll get here, h bar equal to, we can write h bar equal to 1.5 plus 1.5 sin 0.833. So that will be give you 1.5 plus 1.5, it will become some point, something will come value. So this is near about 1.2 will be there, and this is 2.7. 2.7 value will be there. I'm not writing the approximate value because again I need to find out by the scientific calculator exact value how much will be there. So I'm just approximately writing the value here. Now this is h bar value. Now here we can find out the value of total pressure, because total force, pressure force, what is there, F equal to that rho g a h bar, because this is the formula. Previously we know that. Now here rho we know that 9,000 into 9.81 into area, what we got previously 7 point some value will be there, into 2.7 value will be there. So this will be near about 10,000 70,000 into 2.7, 140 49 189. So 190 some value will be there actually. 190, that means 1,90,000 621, some approximate value will come here. 77 is there, 717. Okay, so this is the force, which is pressure force applying on that. Now similarly, the next point is we need to find out the position of the center of pressure, that is nothing but H star. So that we can calculate again, same formula previously what we have given, H star equal to, Ig sin theta divided by AH bar plus H bar. Now here everything we got Ig. Okay, Ig you need to calculate here. Now Ig for here, actually it is a circular lamina or circular plane is there. So Ig will be here different, pi d4 by 64, pi d4 by 64. So this will be the center of Ig value. Okay. Now so that value will be pi d4 by 64, d equal to how much? Diameter 3 to the power 4. So 27, that 81, 273, 43 into 3.14 divided by 64. So this will become near about 64, this one 4, 12, 4 to 12, 11, 11 or 12 near about it will come, maybe I think. D to the power 4, 3, and this will be 3, 9, 27, 81. Sorry, this is 81. Sorry. 81 into 3.14. So that means 243 something will come divided by 64. That means near about 3 or 4 will come. 4. Now here I'll put the value of Ig into sin theta. Sin theta already we got here previously. 4 into 0.833 divided by area. Area again 7. H bar how much we got? 2.7 plus 2.7. So now see 4 into 0.83. So 3.2 near about it will come. 3.2 divided by 7 into 2.7, that is nothing but 14, 49, 18.9. So 3.2 by 18.9. So very less value will come. So 2.7 plus that 0.00 something will come. So we can write this value will be near about 2.8 meter. Okay. So this is the height from this, from here to here. Sorry, this one. Okay, the height from the surface of the layer to this center of gravity point. So by that we can solve this kind of problem when it is when the object is inclined and submerged in the static liquid. So I hope you understood how to solve the problem. If you are having any query and doubt regarding this, you can give a comment in the comment box. Thank you all.